Hi, my name is Vinny. I'm a rising senior at Chaminade High School, and this is the second milestone video for my intensive project, the pulse sensor wristband. First, I'll demonstrate the improvements I made on the device, and then I'll go into detail about how they work. In the first milestone video, my device was wired on the breadboard and powered by my laptop, but now, as you can see, the pulse sensor can run on its own without any cables connecting to the computer. The new power source is this 3.7 volt rechargeable battery to provide portability. I've also added a charging circuit for the battery so you can charge it by plugging into the USB port in the computer. In order to minimize the size, I soldered the Arduino Nano onto the piece of wearable protoboard and raised the OLED screen up to sit right above the Arduino by using male-female headers. As you can see, the device displays my cardiogram and beats per minute just as well as when it was powered by my laptop. And when I take my finger out, both the BPM and IBI goes back to 0. Now I'll explain in detail how the process works. First, I decided to use the 3.7 volt lithium-ion battery because I wanted to make sure that the battery is thin but still powerful enough to run the system. So 3.7 volts is the final compromise. But since the Arduino operates at 5 volts, the 3.7 volt input is simply not powerful enough. So I decided to use this boost converter to step the voltage up to 5 volts. The boost converter I'm using is the Minty Boost from Adafruit. It takes voltage inputs as low as 0.7 volts and provides a steady 5 volt output. And here's how it works. The system relies on the inductor's property to resist changes in current by changing its voltage. Inside the boost converter chip in the middle, there is an internal switch that is switching on and off very rapidly. When the switch is closed, the circuit is shorted so that there's more current flowing to the inductor here. The inductor then stores up some charge by creating a magnetic field. When the switch opens, the inductor has to raise its voltage to keep the current flowing because of the higher resistance in the output. Also, when the switch is open, charge is stored in these two electrolytic capacitors so that when the switch closes again, they can provide the voltage for the output. In the circuit, the switching rate is what controls the amount of charge stored in the inductor. It is controlled by the IC chip so that there's always a 5 volt output. The Schottky diode here makes sure that the current only flows one way from the battery to the USB. And finally, these two ceramic capacitors make sure that the output voltage is accurate and stable by filtering out high frequency noise. Together, all these components make sure that there is always a 5 volt output when there's a smaller input. The output of the Minty Boost is a USB port. So, I use this male-male mini USB jack to connect it to the Arduino, which then powers the OLED screen to display the graphics. The main issue I faced while getting to this milestone was soldering the Arduino onto the proto board right here and also connecting the wires from the pulse sensor. I had to resolder a couple times so that I can make sure that the connections are extra tight. In the next step, I plan to use Velcro straps to make the device wearable and also add an RTC module so that I can display current time on the OLED display.